There are many factors that affect the ability of an airplane to perform under certain conditions. One of these is proper loading of passengers, cargo, and fuel. In this section, you'll learn how to determine if your airplane is within the weight and balance limits which have been established by the manufacturer. Each airplane is designed to be operated at or below specified maximum weights and within a certain center of gravity range. As you learned earlier in the stability section, improper loading can adversely affect performance. In addition, all figures in the performance section of the POH are based on an airplane being loaded within the specified limits. Let's begin our discussion by looking at the various aircraft weights with which you should be familiar. The starting point for any calculation is the basic empty weight, which includes the airplane, optional equipment, unusable fuel, and full operating fluids, including oil.
Payload includes the weight of the passengers and any cargo or baggage. Useful load includes the payload and the weight of the flight crew and usable fuel. The sum of the basic empty weight and the useful load is called the ramp weight, which is the weight of the aircraft during ground operations.
You adjust ramp weight by subtracting the fuel to be used for engine start, taxi, and run-up to get takeoff weight. This weight should not exceed the maximum takeoff weight found in the POH or the weight and balance records. If your airplane is too heavy, it might have trouble getting off the ground. An airplane also has a maximum landing weight. This weight can be determined by subtracting any fuel used during the flight from the takeoff weight. The maximum landing weight can also be found in the airplane's POH. If you operate your airplane above this weight, the shock absorbed during landing may overstress the landing gear or damage the wing support structure. When you have determined that your loaded airplane will not exceed the maximum weight, you need to ensure that it is safely balanced. An airplane is in balance when its center of gravity, or CG, is located within the limits prescribed by the manufacturer. The CG is measured in inches aft of a reference datum, which is an imaginary vertical line set at some point along the longitudinal axis of your airplane. The datum can be set anywhere the manufacturer chooses. Some popular locations are a point ahead of the airplane, the firewall, or the leading edge of the wing. For this airplane, it is located at the nose. The center of gravity for every component is located in relation to this point. The longitudinal distance in inches from the datum is called the arm or station. Since the baggage area for this aircraft is located 142.8 inches aft of the datum, its arm is considered to be 142.8. If you multiply the weight of an object by its arm, you get its moment. For example, the weight of the suitcase is 25 pounds. Multiplying this weight by the arm results in a moment of 3,570 pound-inches. By adding all the moments together and then dividing by the total weight, you'll get the center of gravity for the loaded airplane. It's your responsibility as a pilot to make sure this CG is within limits. To help you accomplish this task, manufacturers use three basic methods. These include the computational, graph, and table methods. Let's first work a problem using the computational or mathematical method. Your first step is to find the basic empty weight and moment in the aircraft's weight and balance records. This figure includes the weights of all permanently attached items. Therefore, if any equipment is added or removed, the weight and balance records must be adjusted. For this problem, let's assume the basic empty weight is 1,500 pounds. This weight and its moment, along with its CG if given, is then transferred to a worksheet which contains 4 columns labeled as shown. You must then complete the weights and moments for the rest of the useful load. As a sample problem, assume you weigh 170 pounds and you're going to be carrying 2 passengers who each weigh 180 pounds. Since one of the passengers will be sitting in the co-pilot seat, you need to add your weight to that of the passenger. The result is 350 pounds. Since the arm for the pilot and front seat passenger is 80.5 inches aft of datum, the moment is 28,175 pound-inches. The moment for the rear seat passenger is 21,258 pound-inches. The next major item is fuel. Since you intend to carry the maximum amount of usable fuel, which is 48 gallons, and since each gallon of avgas weighs 6 pounds, the total fuel load weighs 288 pounds. This weight times the arm of 95 inches yields a moment of 27,360 pound-inches. The last item is the baggage, which in this problem weighs 60 pounds. Its moment is 8,568. If no more items are loaded on the airplane, the computational list is complete. Your next step is to add the weight and moment columns. In this example, the total weight of the loaded airplane is 2,378 pounds. And the moment is 214,211. You should then verify that the total weight is less than the maximum weight found in the POH or the weight and balance records. If not, you will have to make a choice of not carrying as much fuel, taking less baggage, or leaving some of the passengers behind. You can now determine the center of gravity for your airplane by dividing the total moment by the total weight. The CG with this loading is located 90.1 inches aft of the datum. To determine if the CG is within limits, refer to the airplane center of gravity limits graph. In this example, the numbers on the right represent the airplane's weight, and the numbers on the top represent the CG location. Enter the graph on the right at the number that matches the total weight of the airplane, which in this case is 2,378 pounds. Then move to a point just right of the 90-inch aft CG location. Since this point falls within the approved CG envelope, your airplane is properly loaded. Some aircraft manufacturers use the graph method, which is a simplification of the computational method. It allows you to determine the moment of each item without having to multiply each weight by its arm. In this example, assume this airplane is carrying the same load as before. To find the moment for yourself and your front passenger, enter the graph from the left side at 350 pounds. Proceed horizontally to the pilot and front passenger line. Then drop straight down and read the moment divided by 1,000. In this case, it is 13.0. Enter this moment in the appropriate space in the worksheet. Then follow the same procedure to find the moments for the remaining items. Once you have all the items listed and totaled, you must compare the total moment with the total weight to determine if your airplane is within limits. Notice that with this type of graph, you don't have to do any calculations to determine the center of gravity. Another simplified method of determining moment is the table method. It requires only that you locate a given weight, then find the corresponding moment. Notice that the moments in this table must be multiplied by 100 to compensate for the reduction factor. Also, if a single weight exceeds the limit, you should use 2 lower weights which, when added together, equal the single weight. For example, You know that you and the front passenger weigh 350 pounds. Since the table only goes to 200 pounds, you'll need to find the moment for yourself and then add it to the moment for the front passenger. You then need to transfer the weights and moments to the weight and balance worksheet. Once you've finished totaling the weights and moments, you can use the moment limits versus weight table to determine if you're within limits. Here, you must find your loaded weight and then verify that the total moment is within the minimum and maximum limits. Weight and balance is a factor that should be considered on every flight. Taking the time to verify that your airplane is properly loaded will increase performance and help ensure that you have a safe flight.